This was our Z180 computer at the end of the last video. It's sitting in the bottom half of the case but is not yet screwed in. The kit does ship with an FTDI cable, but I've plugged in a known good cable I've used previously, just to eliminate any cable problems with the first power up. As you can see, the cable is plugged into the first serial port, port A. It's very important you plug this cable in the right way round to prevent any issues. This USB connection is how you communicate with the Z180 computer. The board has no video output, so you'll need to use a communications package like TerraTerm to control it. The cable that ships with the kit will do the job perfectly, but as you can see, the small circuit board is not encased and could be damaged with rough handling. Again, you'll have to take care when plugging this into the main board. The kit does have two serial ports, and if you wish to power the unit off of port B, you'll need to fit a jumper to JP2. So today we're going to attempt to power up the board for the very first time, and we should hopefully see some activity on the LEDs on power up and when the reset button is pressed. So now we have our Z180 computer attached to the main computer, it's time to check to see which COM port it's using, and then launch TerraTerm. Launching the device manager allows us to see that COM6 is the port we will be using. The next step is configuring TerraTerm's serial port to COM6, setting the speed and the flow control to none. With this in place, we then merely have to click the reset button on our Z180 computer for it to output to the TerraTerm window. And there we have the first output, giving us details of the computer's configuration coming from the bootloader. I've already added an 8GB micro SD card to the slot on the Z180 computer. We can see that there is a 512KB ROM and a 512KB RAM in the system, giving us a full 1MB. The clock speed of this particular Z180 is just over 18 MHz. While slow by modern standards, this would have been really fast in the 1980s for a Z80 style system. Pressing H for help provides a list of options, amongst which are listing the applications on the ROM, performing a device inventory, and rebooting the system. So let's list the applications first. And try Basic from the ROM. And go ahead and write a simple program. While this version of Basic does give you more memory to play with, I suspect that it won't recognise the SD card, and we'll need to use the Basic within CPM to achieve that. However, as we've done before, you can write your applications on your main computer, save them there, and just paste them into the TerraTerm window. I can never remember the command to exit Basic and return to the bootloader. Ah yes, it's the word bye. So let's list the ROM applications once more and go into CPM. As you can observe, we have a list of drives. A is your RAM disk, B is your ROM, and the remaining drives are from the SD card, each of which is 8 MB. If we list the files on the B drive, we can see all the CPM applications. The A drive is empty, and if we list the C drive, it will show an odd format. At this point, it's worth looking at the documentation for the ROM WBW. I'll put the link in the description below. This documentation provides invaluable information on how to utilise and configure the system. Today we're looking at disk management, specifically on how to configure and use our SD card drives. Information on all types of storage are supplied, and a lot of very good advice provided. In the section on disk preparation is contained the information we require to effectively format our SD card drives. there is a command we need to run to ensure the drive is properly set up for CPM, and that command is clr-dir, clear directory. Obviously, as this command will format and wipe anything on the SD card, we have to be sure to run it on the correct drive. And it also helps if you type the command correctly. The command will prompt you to confirm that you have picked the correct drive before continuing. Once run, we can then use a dir command to list files on the drive, which now correctly returns no file. So our C drive is now ready for use. The same command will of course need to be run for the remainder of the drives on the SD card. So popping back into CPM once more from the bootloader, let's run basic from the B drive. And we're going to create a program and save it to the C drive. Exit and then load it up again from that C drive to prove our disk storage is working correctly. So if we use the save command and in double quotes specify the drive and the file name to save to, it appears to have saved correctly. So let's now back into CPM and check that the file arrived. And there is our file. Once more into BASIC and let's load the file back up. And there is our file successfully loaded and listed on screen. So I think our SD card storage is fully operational. So what else can we do with this system? Let's go into the Monitor application and have a look at the help provided. These low-level commands allow you some fine control over the system. So we're going to write a very simple program in machine code to copy data from one location to another. We'll first use the dump command to list on screen data from a specific memory location. As we are running at the machine code level, all the numbers you'll see are expressed in base 16, that's hexadecimal. So as we are listing from 9100 to 9120, this will display 20 bytes, but that's 20 in hexadecimal. So we're going to use the p command to enter our program. This will store 9100 in the HL register pair. This number has 2 bytes, loaded in backwards. It seems odd, but you get used to it. We then load the DE register pair with the destination, which is 9200. Finally, the BC register pair is loaded with the number of bytes to copy. Finally, we use the ldir command to copy from the source to the destination for the number of bytes specified, and finish with a C9, which is a return command. Before running, it's always best to dump out your code to check that it is correct. And there is our simple program. So let's list the destination to see what is there at the moment. We can use the fill command to zero out all the bytes at our destination. So now that we have wiped the data at the destination, we can attempt to run the code, and then dump out the data to ensure that the copy has been successful. And there we have the destination with the data. These commands I've used are standard Z80 machine code, which runs fine on a Z180 processor. The Z180, of course, does have an expanded instruction set. So now that we have tested the computer, we can fit it into its case. Adding firstly the supplied adhesive feet to prevent it sliding around on your desk. Then carefully aligning the front and back panels before sliding the assembly into the case. Fixing screws are provided to connect the board to the base. And once the top has been fitted, 2 further longer screws hold this in place. The final test is of course to power it back up to ensure everything still works. Hopefully you have found this video useful and informative, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.